Where else but NAPA chassis parts can you find parts like these? Parts that last, and last, and last. Parts that fit as well in the cars you work on as they feel in your hand. And where else but NAPA chassis parts can you find coverage like this? Thousands upon thousands of parts for literally hundreds of car models, imports and domestics. For hundreds of light trucks, old and new. And even complete steering and suspension coverage for more than 800 heavy-duty truck axles. But quite frankly, we're not just in the business of parts. We also back you up with the kind of technical support you need. Through intensive training classes at our research facility in Michigan, and our mobile NAPA chassis parts tech vans that prowl the land, where you get to rub elbows with the people who are working side by side with the world's foremost OE manufacturers. Because at NAPA Chassis Parts, our people are pushing the envelope of high-performance technology on some of the fastest tracks in the world. So the technical advances we perfect here can be found in the parts and components you install here. And as the technology continues to change, we're committed to helping you stay ahead, which is why we're bringing you the training program you're about to see. Because at NAPA Chassis Parts, there's more in the box than just the part.
The topic of this program is steering and suspension inspection and troubleshooting procedures. In this program, we'll cover the information you need to know to perform a complete inspection and troubleshooting procedure for steering and suspension systems.
The inspection and service that you perform on these systems is critical to safe driving and dependable vehicle operation. With most drivers going to self-service gas stations, the visual inspection that used to occur whenever a vehicle came in for gas is long gone. What you have to concentrate on now is that whenever a vehicle comes in for service, even if it's for an oil change or a tune-up, you should look over the steering and suspension systems to assure that they're in good working order. Doing so will provide two major benefits.
First, you're assuring that your customer is driving in a safe and dependable vehicle. Second, you're opening up more potential service profits.
Let's face it, the more work you do, the more money you make. And the more satisfied your customers are, the more business you get. Now in this program, we're going to take a general look at inspection and troubleshooting. Then we'll get specific to vehicle types.
We've selected three popular vehicles to examine. They are a front-wheel drive import, in this case a Honda Civic, a rear-wheel drive domestic automobile, which is a Ford Crown Victoria, and a domestic four-wheel drive where we're featuring a GMC pickup. The principal point to be aware of in your inspection is that it is not complicated. The inspection is primarily made up of visual checks of system components. What is most important is your ability to draw conclusions from your inspection to perform any necessary troubleshooting and repairs. Now, you may ask, when should I perform this inspection? As I said earlier, a quick visual inspection should be performed anytime you have a vehicle in for service. A more thorough inspection should be performed if the vehicle is in for wheel alignment or the owner complains of specific steering or suspension problems. Abnormalities or malfunctions will affect wheel alignment, so you'll have to make your inspection and any required repairs before an alignment is performed.
Now, before we get too far along, let's review some basic alignment terms that you should be familiar with. Specifically, camber, caster, and toe.
Camber refers to the vertical position of the tire in relation to the vehicle. Positioning the top of the tire away from the vehicle indicates positive camber. Positioning the tire with the top toward the vehicle is negative camber. Camber adjustment primarily affects tire wear, although it does have some directional effects. Caster applies to the angle of the steering axis relation to the tire and wheel. The steering axis leans forward, negative caster, or rearward, positive caster, depending on the application. Caster is used primarily for directional control. Toe refers to the angle of the tires relative to the center line of the vehicle when viewed from above. Zero toe exists when the tires are running parallel. If they are closer together at the front than at the rear, it is called toe in. If they are closer together at the rear than at the front, it is called toe out. Typically, a slight amount of toe in is provided while the vehicle is at rest. Toe in returns to zero toe as dynamic forces develop when the vehicle goes down the road. It is important to note that toe is the most critical angle to set for proper tire wear. Also, many front-wheel drive cars have a toe-out setting. This is due to the dynamic forces associated with front-wheel drive.
Now let's talk about how to perform basic inspection and troubleshooting. This is a general look and applies to all vehicles. What I want you to note is the method that's used. I like to start at the outside of the vehicle and move inward, beginning with the tires. The first part of the inspection occurs with the vehicle on the ground.
What you should be looking for on tires is correct pressure and size according to the manufacturer's recommendation. You won't find the manufacturer's recommendations on the tire itself. They're usually on a decal on one of the door jambs or some other easily accessible spot. On the decal, you'll find recommended tire sizes along with the proper tire pressure. The pressure usually found on the tire sidewall is a maximum pressure and is probably not the same as the manufacturer's recommendation for best ride and performance.
Remember too, tire pressure should be checked cold. Tires that are warm from driving cannot be accurately checked for pressure. Tire size is also very important. All the tires should be the same size and load rating, and should be a size recommended for the vehicle.
Tire sizes between the front and rear don't necessarily have to match on two-wheel drive vehicles, especially trucks and some high-performance vehicles, but it's absolutely essential that tires are the same size side to side. Also, the tires on four-wheel and all-wheel drive vehicles must be the same size all the way around, otherwise severe drivability and driveline problems will occur.
Once you've checked tire pressure and size, you should look over the condition of the tires. First, how much tread is there?
If the tread wear indicators are showing, it means there is excessive wear and less than 1/8 inch of tread left on the tire. Tires in this condition should be replaced.
Second, check the condition of the tread to see if there's any unusual tread pattern that would indicate an alignment or suspension problem. Here are some examples.
Tire worn on the outside edges has been run underinflated. You might want to check it for a leak. A tire with just the center worn down has been overinflated. If a tire is worn on only one side, it's a pretty good indication of an improper camber or toe adjustment. A bad toe adjustment can also cause a feathering or sawtooth condition on the tire. This condition is caused by the tire skidding during its regular revolution. It can also occur if the vehicle is subjected to frequent high-speed cornering.
This is something you'd have to feel to detect, since the tire may look perfectly good, as this one does.
Now, bald spots or a scalloped effect on the tread can indicate problems like an unbalanced tire or wheel, a tire defect, or possibly worn suspension components. Another condition to be aware of is diagonal wipe. This condition can occur on the rear wheels of front-wheel drive cars and is caused by the tires not being parallel to the road.
After checking the tires, take a look at the vehicle to see if there's a noticeable side-to-side lean. A measurement can be made from the floor to the wheel well lip through the center of each wheel to see if a lean condition is present. Remember, loads placed in the vehicle may affect this measurement, so make sure no undue weight is placed in the vehicle.
In cases where permanent equipment or luggage makes a significant change in curb height, you should make every effort to correct the curb height through the use of heavy-duty shocks, variable rate coil springs, or other methods. But toe adjustment should be made with the additional equipment in place. To help you in making ride height measurements, NAPA Chassis Parts has a ride height specification manual available that applies to most cars and light trucks. This manual provides you with instructions for the points to make measurements along with vehicle specifications.
Keep in mind that a sag or lean condition is usually not repairable through the installation of hydraulic shocks or struts.
This condition should be repaired by replacing springs or adding shims or spacers as recommended by NAPA Chassis Parts or the manufacturer. Remember, springs should always be replaced in pairs.
You should also give the vehicle a quick examination for damage. Look for damage to wheels that could indicate a hard blow. Also, look at the body for dings and dents, or evidence of sheet metal repair that could indicate the vehicle has been in an accident. Remember, collision damage or a bad repair job can change suspension geometry and cause alignment and handling problems.
Another thing to look for is a trailer hitch. This could be evidence of unusually heavy loads that may be affecting the vehicle. After making these checks, the vehicle should be raised to continue the inspection. But first, let's review what we've covered so far. Here are a few questions for you. Number 1, typically, what does the tire pressure specification on a tire sidewall indicate? A, proper tire pressure for the vehicle. B, maximum tire pressure. C, minimum tire pressure. D, recommended tire pressure when warm. B, maximum tire pressure. Number 2, what is the primary purpose of caster? A, directional control. B, reduce tire wear. C, improve high-speed control. D, compensate for dynamic road forces. A, directional control. Number 3, what is the cause of a tire worn in the center of the tread? A, underinflation. B, improper camber. C, high-speed cornering. D, overinflation. D, overinflation. Let's go through a general under-vehicle inspection. Start by checking the wheel bearings. To do this, grab the tire at the top and bottom and give it a good shake. If it moves excessively, say more than 2 or 3/100ths of an inch, there could be a loose or bad bearing. If there is an indication of a wheel bearing problem, be sure to check all 4 bearings and replace any that are bad. The next check is for ball joints. These are joints on which the wheel pivots. To make this check, the ball joints must be unloaded. Rock the wheel up and down while looking for ball joint movement. In most cases, movement greater than 1/32 of an inch of the upper or lower ball joint indicates excessive wear and the ball joint should be replaced. Also, keep in mind that ball joints are usually replaced in pairs. Not all vehicles have ball joints. You'll find some trucks equipped with kingpins. Kingpins function as the pivot for the steering knuckle and are supported by bushings. Check for kingpin bushing wear by attempting to move the tire and wheel assembly in the same manner used to check ball joints. If there is excessive play, the kingpin and bushings must be replaced.
Note that worn ball joints or kingpins can cause a number of handling and steering problems and should be checked carefully if the vehicle owner gives you any reason to suspect a problem. This especially applies to older or high mileage vehicles.
Another check that can be made at the tires is a steering mechanism check. Here you move the wheels in and out and watch for movement at the steering pivot points. If there is movement, it will be necessary to replace the loose components. Also, you should check all the steering components individually by trying to move them. Check the tie rod ends for looseness or damage. Check the center link for looseness or damage along with the idler arm and the pitman arm if equipped. If looseness or damage is present on any of these components, they should be replaced. Once you've checked over the steering linkage, take a look at the steering gear. It should be mounted firmly with all fasteners in good condition. Check seals and boots for rips, cuts, or leaks, and correct them as necessary.
After checking the steering, turn your attention to suspension system components. You should be looking for signs of wear and damage.
Look at the shock absorbers or struts and note any looseness to the mounting, damage, or any sign of leakage on the barrel. If a leak is present, the shock must be replaced. A point that you should note about shock absorbers in any application is that a slight amount of oil seepage is normal. This seepage may draw dust and give the appearance of a leak, but is not an indication of a malfunction. A leak will appear as a very wet oil spot on the shock. You should also inspect the suspension bushings. Look for cracks or dry rotting of the bushing or conditions where the rubber is crushed out of the housing. Keep in mind that bushings are the key to a smooth, safe ride, especially in today's smaller cars, so if there is wear or damage, replace the bushings. During replacement, you may find it advantageous to use synthetic bushings, which are impervious to oil and resist ozone damage. NAPA chassis offers a large selection of high-quality Sanoprene bushings to meet this need.
You should check the springs for cracks, breakage, and correct mounting. On coil springs, look for conditions of coil binding, and on leaf springs, check the center pin alignment. Also, be sure to check the rear suspension, too.
Take a look at shocks, springs, control arms, sway bars, and other components. Problems at the rear of the vehicle can affect overall handling and must be corrected before performing any alignment.
You know, there's another factor that can play a major role in inspecting and troubleshooting steering problems, and that's dragging brakes.
Now, to check dragging brakes on driven wheels, simply give the wheel a spin. It should spin freely and not slow down abruptly. To check for dragging brakes on drive wheels, put the transmission in neutral and have a second person apply a very light pressure to the brake pedal. Then spin the wheel to feel the amount of drag and observe how quickly the tire stops. Now release the brake and again spin the wheel with the same force, noting the difference. If the brakes are not dragging, the tire should turn easier and spin longer before it stops.
Okay, so far we've discussed general inspection and troubleshooting methods that are performed in the shop. That's not the whole story, though. You should also include a test drive in your inspection.
The best thing about a road test is that you can verify the problem. After you've performed the required service, you can road test again to verify the repair. This is absolutely essential to having a satisfied customer. Choosing where you make your road test is one of your most important decisions. You should road test in an area that's lightly traveled and as close as possible to the conditions under which the owner drives most often. During your test, there are several things to look for. Let's take a look at them. The first is pull. Pull is a condition where the vehicle tends to drift consistently in one direction. This is usually the easiest condition to find. Pull can be caused by a problem with suspension or steering components, or it could be an indication that camber or caster is in need of adjustment. The next condition is wander. Wander is similar to pull, except the vehicle requires correction in both directions to keep it traveling in a straight line. Wander can be caused by a problem in the suspension or steering systems, a toe-out condition, or possibly an improper caster adjustment. You must also check the action of the vehicle during cornering. To do this, make full 90-degree turns in both the left and right directions. Check the action of the steering mechanism, especially steering wheel return, and also the amount of lean during a turn. Problems in cornering may indicate worn or broken components in the steering or suspension systems or improper wheel alignment. Throughout your road test, you should check for nibble and shimmy. These conditions are indicated by short, rapid back and forth movements of the steering wheel while driving straight ahead on a smooth road at constant speed. Nibble is tire related and can be caused by an improperly balanced wheel, excessive tire runout, or an out-of-round tire. Shimmy is steering and suspension related and can be caused by worn ball joints, kingpins, or damaged steering or suspension components. Another condition that you should be looking for is a constant vibration that occurs at specific speeds or above certain speeds. The most frequent cause of this condition are tires or wheels out of balance, along with loose suspension components, idler arm, or tie rods. Excessive tire or wheel runout may also contribute to this condition. To check tire and wheel runout, use a dial indicator to assure runout is within specifications for the vehicle you are servicing. A point to remember about excessive runout is that it could be caused by improperly repaired structural damage that may have to be corrected before making other checks or performing an alignment. Number 1. What is the function of a ball joint? A. Acts as a pivot for a steering knuckle. B. Absorbs up and down movement of control arms. C. Absorbs back and forth movement of the control arms. D. Acts as the wear point, bushing, for wheel movement. A. Acts as a pivot for a steering knuckle. Number 2. How should you react to slight seepage from a hydraulic shock absorber? A. Replace the shock absorber. B. Rebuild the shock absorber. C. Consider the condition normal. C. Consider the condition normal. Number 3. Road testing a vehicle after performing a repair allows you to A. Verify the problem. B. Verify the repair. C. See if there are any other problems. D. Meet with the customer and discuss the malfunction. B. Verify the repair.
Okay, up to this point we've talked generally about inspection and troubleshooting. Now let's get vehicle specific so that you can take the information that you've learned and apply it to particular vehicles. I've reviewed the inspections on a front-wheel drive Honda Civic, a rear-wheel drive Ford Crown Victoria, and a four-wheel drive GMC pickup. I'd like to share the information that I've found with you. Let's start with an inspection of the Honda Civic.
To begin your inspection, it's a good idea to go for a test drive and try to verify any customer complaints. After the test drive, take a look at the vehicle. First, check the tires to assure they are all the same size and they are properly inflated. Remember, if the tires are still hot from driving, give them a chance to cool off before checking pressure. While you're checking the tires, look at the wheels to see if they are damaged and check the tread wear on each tire.
Any problem present with the tires or wheels may be the cause of a problem or could lead you to a specific malfunction. If you suspect a problem with wheel runout, Honda recommends that you check axial runout and radial runout.
The specification for axial and radial runout is the same, although there is a difference in the spec for steel and aluminum wheels. Once the tires and wheels have been checked, measure the curb height as we described earlier and compare it to the NAPA chassis parts ride height specification manual. A sag at one corner of the vehicle or a significant change from the specified dimensions may indicate a problem. That takes care of the checks that can be made with the vehicle on the ground. Now it's time to lift it and make the rest of the inspection. With the vehicle in the air, move the wheel in the ways we described earlier to check ball joints, steering mechanism, and wheel bearings. A point to note on the Civic is that Honda provides a specification for wheel bearing end play. Using a dial indicator, you can make this check. The specification is 0.05 millimeters. Moving inward, let's take a look at the steering and suspension components. The function and appearance of these systems, especially the suspension, is quite different than other vehicles, domestic or imported. The suspension system is sometimes called the wishbone design because of the appearance of the fork assembly, which attaches the damper assembly to the lower arm. What you need to understand about this system is that it is not a McPherson strut. In the Civic, the weight is supported by the steering knuckle, not the strut. This is a damper assembly that simply combines the shock and coil spring in one unit. The damper should be checked for oil leaks in spring condition. As far as the suspension goes, you've got two ball joints, an upper and a lower, plus bushings at almost every joint. Take a close look at all these components and try to move things around to determine if there is any looseness. A check that could easily be overlooked is for the upper control arm bushings. To check these bushings, grasp the steering knuckle and try to move it back and forth. If the steering knuckle moves, it means that the upper arm bushings have deteriorated. The steering system is actually quite straightforward. Tie rod ends transfer the movement of the rack and pinion steering gear to the steering knuckle. Make sure that the tie rod ends are not loose. Also, check the steering gear for proper mounting and for any leaks, either from the boots, power steering hoses, or from the rack seals.
You should remember that because of the proximity of the steering gear to the transaxle assembly, fluid leaks coming from the transaxle could be blamed on the steering gear, or vice versa. Make absolutely sure that you know the source of a leak before making repairs.
Finally, take a look at the CV joint boots to assure they are not torn or deteriorated. Moving to the rear suspension, make similar checks to the ones performed on the front of the vehicle, specifically for bearing end play. There are several components in the rear suspension, all attached through bushings. You should check the trailing arm, upper arm, lower arm, compensator arm, and stabilizer link for damage. Check all of the bushings for deterioration or damage and replace as necessary. Also, take a look at the condition of the stabilizer bar and its related bushings. Like the front suspension, a damper is used instead of a strut. Check the damper for any oil leaks and look the spring over for cracks or other damage. Well, that's a brief look at the current Honda Civic. This is also representative of the Prelude. Number 1. What tool should be used to check wheel bearing end play on a Honda Civic? A. Vernier caliper. B. Machinist's scale. C. Dial indicator. D. Tape measure. C. Dial indicator. Number 2. On the Honda Civic, what component supports the weight of the vehicle at the front? A. Strut assembly. B. Control arm. C. Spring. D. Steering knuckle. D. Steering knuckle. Number 3. What component should be checked for leakage if fluid appears on the Civic's steering gear? A. Engine oil pan. B. Transaxle. C. CV joint. D. Wheel bearings. B. Transaxle.
Now let's move to another type of vehicle, a domestic rear-wheel drive, specifically the Ford Crown Victoria. This system is quite representative of large American-built cars.
The initial checks of tire pressure, tire size, tread, and wheel condition all apply to the Crown Victoria. You should also check the curb height at each corner of the vehicle to assure it complies with the NAPA Chassis Parts Ride Height Specification Manual.
A point that you should note about the Crown Victoria and some other Ford and Lincoln Mercury rear-wheel drive models is that the lower ball joints should be checked prior to lifting the vehicle or with the tire in the normal driving position.
To do this, wipe the grease and dirt away from the grease fitting and checking surface. The checking surface is the round boss that the grease fitting screws into. If the checking surface extends out from the ball joint cover, the joint is okay. If it is worn below the inside of the cover, the lower arm assembly must be replaced. NAPA Chassis Parts offers an improved design wear indicator ball joint. Our indicator is separate from the grease fitting and utilizes a pin that can be felt. When the ball joint is worn, the pin recedes into the ball joint housing. The use of a NAPA ball joint makes inspection quicker and easier. With the vehicle raised, make the wheel bearing check. There are 2 points that you should keep in mind about loose wheel bearings. First, on the 1991 and prior Crown Victoria models, wheel bearings should be retightened according to procedures contained in the Ford shop manual and other popular maintenance manuals. Worn or damaged bearings should be replaced. Second, on 1992 and later models, the hub and bearings are integral. Any noticeable bearing play can only be corrected by hub and bearing replacement. Wheel bearings cannot be retorqued. Once you've assured that the wheel bearings are tight, check the upper ball joint. With the lower control arm on a jack stand, have an assistant grasp the lower edge of the tire and move the wheel in and out. While the wheel is being moved, observe the upper end of the spindle and the upper control arm. Any movement between the upper end of the spindle and the upper control arm indicates excessive ball joint wear and requires the installation of a new ball joint. Make sure the springs are in good condition and that there is no oil leakage from the shock absorbers. Moving inward, check the condition of the upper and lower control arm bushings along with the steering-related components. All components should be tight and firm when grasped. Also, don't forget the stabilizer bar and bushings. Look for any deterioration of the rubber or looseness of the mounting. Check the steering gear for a firm mounting on the frame and for any leaks from hoses or related seals. Note that the steering gear in this application is a recirculating ball type instead of the rack and pinion which we saw on the Honda Civic. After completing your inspection of the front, take a look at the rear suspension components. In the case of the Crown Victoria, there are 3 major types of components. They are the suspension arms, air springs, and the shock absorbers. During your inspection, check the suspension arms for any damage or looseness and also for bushing wear. Check the springs for damage and finally, make sure the shocks are not leaking and the rubber grommets are in good condition.
If the vehicle is equipped with a stabilizer bar, make sure that any bushings associated with it are in good condition and that it's tightly mounted.
Number 1. What best describes the checking surface on Crown Victoria ball joints? A. Round boss. B. Scored boss on upper part of ball joint. C. Checking surface is the grease fitting. D. Checking surface is on the opposite side of the ball joint from the grease fitting. A. Round boss. Number 2. Which year Crown Victoria does not have adjustable front wheel bearings? A. 1989, B. 1990, C. 1991, D. 1992. D. 1992.
The final vehicle that we'll be inspecting in this program is a 4-wheel drive K-Series GMC pickup.
Begin your inspection in the same manner as on the other vehicles, which is to check the tires for proper size, inflation pressure, and tread wear. Next, measure the height at the 4 corners of the vehicle to assure that there is no side-to-side sag. Also, check the distance between the center line of the lower control arm mount and the lower corner of the steering knuckle. This height must meet specifications prior to adjusting caster, so it is a check that you should make if you're going to do an alignment. The distance is controlled through torsion bar adjustment. The actual inspection of the K-Series is quite detailed and requires care. Once the vehicle is lifted, check the front wheel bearings. There should not be any back and forth movement of the tire. If there is, it means that the wheel bearing and hub must be replaced. Wheel bearing torque is not adjustable on the GMC four-wheel drive. The ball joints must be checked using a specific procedure. This is accomplished by supporting the vehicle at the outermost point of the lower control arm. In this position, the vehicle must be stable and not rock, and the upper control arm bumper must not contact the frame. Place a dial indicator against the spindle to show vertical movement, and then pry between the lower control arm and the outer race of the constant velocity joint while reading the dial indicator. If there is more than 2 millimeters of movement, replace both the upper and lower ball joints. A point to note is that you should not pry between the lower arm and the drive axle seal, or in such a manner that the ball joint seal is contacted. This would damage the seal cover and require the replacement of the ball joint. Once the ball joints are checked, take a look at the tie rod ends and relay rods to assure there is no excessive looseness. If there is, replace the component. Next, check the idler arm. If the movement is beyond manufacturer's specs, replace the idler arm. Jerking the right tire back and forth, causing an up and down movement of the idler arm, is not an acceptable testing procedure in this instance because there is no control on the amount of force being applied to the idler arm. For accuracy, GM recommends this check be performed with a spring scale. Other checks that you should make on the front steering and suspension include checking the pitman arm for looseness or damage, checking the steering gear for a solid mounting, checking the CV joint boots for tears or damage, assuring that the torsion bars are not damaged and are solidly mounted, checking the shock absorbers and steering damper for any leakage or damage, and checking for any damage or deterioration of the suspension system bushings. Now let's move to the rear of the vehicle to continue our inspection. Note that leaf springs are used here. These springs are mounted through bushings at either end. You should check the condition of these bushings to assure there is no damage or deterioration. Also, check to make sure that the fasteners are in good condition and there are no cracks in the leafs or U-bolts. A point to be aware of is that spring breakage will normally occur at the center of the leaf, where stress is highest. You may have to wire brush the sides of the springs to spot any cracks. After checking the springs, take a look at the shocks and make sure that there is no leakage or exterior damage.
Well, this concludes our look at 3 different vehicle suspension systems. In general, the best thing for yourself and your customers is to perform a thorough inspection and try to isolate problems. Also, being thorough means increased sales for you and a customer that's safer and more satisfied.
Number 1. What vehicle condition does the Z height pertain to? A. Front end sag. B. Rear end sag. C. Tire wear front. D. Tire wear rear. A. Front end sag. Number 2. Front wheel bearing torque on a GMC four-wheel drive is A. Adjustable with a torque wrench. B. Adjustable using a dial indicator. C. Not adjustable. D. Not adjustable when the vehicle is in four-wheel drive mode. C. Not adjustable. Number 3. How much force should be placed on the idler with a spring scale when checking for wear? A. 10 pounds. B. 15 pounds. C. 20 pounds. D. 25 pounds. D. 25 pounds.
Thanks for watching, and good luck on your steering and suspension service.
It's been almost a year and a half in the making. Every detail has been checked and rechecked, and then checked again. And now, it's here. The PowerTech series. Don't think of it as training. Think of it as your future.
Hi, and welcome. This is the first edition of PowerTech. We hope to make it the most up-to-date, the most useful, and the most professional training series on the market.
You need to keep up on the rapidly changing technologies of automotive repair. And that's what these programs, the PowerTech series, are all about. Pat Goss, one of the automotive aftermarket's leading experts on automotive repair and training. He's been the repair specialist on TV's Motor Week program for close to 10 years. He's served as technical advisor to dealer associations for manufacturers around the world, including GM, Ford, Chrysler, Volkswagen, and British Leyland. And maybe most important of all, he has also owned and operated his own automotive repair shop in the Washington, D.C. area since 1970. Now, he's teamed up with NAPA Chassis Parts and XL's Video to develop the most effective, the most specific, the most hands-on training videos the automotive repair industry has ever seen.
In order to get training programs of this caliber, the only thing that I would be able to do would be able to send my guys off to school. And if I send them off to school, they can't work all day and then go to school at night because they're exhausted. You know, they'd like to come home and eat supper and have a little bit of family time. So the only other thing would be an expensive one-week training somewhere, and the average shop can neither afford the time nor can he afford the amount of that school that it costs. So with the flexibility of being able to train when we want to train is the most important thing for us.
Take advantage of the most intensive and complete automotive repair training tools ever. Call 1-800-POWER-XL right now to order your PowerTech video. The price? Just $39.95 for one PowerTech program. Mastering the four-wheel alignment, four-wheel steering diagnostics and repair, or inside all-wheel drive, the systems and technology. Or save almost $30 by buying all three for just $89.95. That's right, you can get all three of these amazing programs complete with tech sheets for just $89.95, or less than $30 per program. Chances are you'll pay for all three with the first repair you make. So have your credit card handy and call 1-800-POWER-XL. Or call your nearest NAPA store and ask about the remarkable new PowerTech series training system. And remember, every day that goes by is a day you could be missing out on the kinds of repairs your customers count on you to make. Call 1-800-POWER-XL today, or call your nearest NAPA store and turn on the power of PowerTech training.
I can assure you that I'm going to be one of those guys that are bugging you guys for these PowerTech tapes, because I'd like to put those in my library so that I can keep my guys training.